In this video, we are continuing our discussion of the data management process and data management workflow. Previously, we have looked at the process for importing our comma delimited file into Excel. And now we are ready to begin recoding the narrative responses into quantitative values so that we can in turn import into the SPSS software and begin conducting our analyses. Now, in order to begin this process, the first thing that we must do is return to our actual survey and begin to develop the code book that we will use for assigning numerical values to the various words that were captured and imported as part of our data into Excel. So if we look at a few of the sections of the sample survey that we're working with, we see that the first section and correspondingly the first set of questions that we will work with all respond to as yes, no, or I don't know. And so again, if we take a quick peek and look at what we had in Excel, notice that all the responses came in as the yes, the no, or we have the do not know. In terms of that's how, if we assume, for example, we distributed this survey through SurveyMonkey, this is how the responses in the data set would actually come back. So even though we knew what numbers we wanted one to, or yes to represent and no to represent, SurveyMonkey does not know that, and we don't have a mechanism for assigning those within that system, and so therefore it just knows this person marked yes, and so it records a yes. Now, as we return back to our survey, then essentially what we have to do is what we did previously when we talked about scale and measurement, and that is convert the yes, no, I don't know into numerical values. Now, if we look at these and when we do take the scale and measurement into account, essentially at this point we would be working in the recruitment section here specifically with nominal scale measurement. We either have basically a presence or absence. Again, if we were to assign, let's just say for example, yes to be 1, no to be 2, I don't know to be 3, then again, the notion of a 3 being greater than 1 is not relevant in this case. It simply doesn't apply within the context of this question. So getting a 3 does not imply that someone likes helping other people more than someone with a 1. So with the fact that we have a nominal scale, what that effectively means then is that our choice of numerical values or the values that we choose to assign to these three different labels really doesn't matter in the sense that we could choose yes to be 1, no to be 10, and I don't know to be 20 if we want to. It really doesn't matter because at the end of the day we're not going to be able to calculate means or various statistics that the actual values would matter. All we're going to do is be able to run frequencies to say how many yeses, how many nos, how many don't knows were in the data set. Now, having said that, there are generally some standard conventions that are used. One of those is to use no as 0, yes as 1, and then don't know can kind of become an arbitrary value. In some cases, people will use very extreme values. They might assign 99 to be I don't know. It just something other than, say a 2. So it's something that's distinct enough that we don't run the risk of just inadvertently entering that number. And also later on, we might want to filter out the don't knows, and so if we assign 99 to always represent that particular type of response that we want to filter out, even if it's in another section of the survey, then it makes life a lot easier, because we can actually do a batch delete by specifying that we want to take out all cases that have a 99, or we might just want to replace all the 99s with a missing value, and so we just take that actual response out. So in this case, let's just say our decision is to use no will be a 0, so we have the absence. Yes will be a 1. And then for the I don't know, we'll go with an extreme and say 99. Now as we scroll down through the survey, we have the question of where did you receive your initial training, and we have 5 different options. Again, we can go down and just simply start with 1, 2, 3, 4, and then the don't know. Again, depending on the nature of the question, again, if we know that don't knows, we want to filter them out. We could certainly, again, just let the don't know be 99. And then moving on down, we have a rating system where we have excellent to poor, and then we have not offered, and again, we have a don't know response. Now, again, because we're dealing with numbers, in this particular situation, we have poor to excellent, so we do have what would appear to be an ordering of our responses. And so we do want to be a little more cautious and a little more thoughtful in terms of how we assign these numbers. Now, there is a tendency, because we naturally read left to right, if we were going to do, for instance, just focusing on the excellent to poor, we have a 4-point or a 4-item response option. And so there's a general tendency to say, well, let's just use 1 through 4. That's perfectly fine. Again, because we're naturally left to right, there's a tendency to have excellent 1, good 2, fair 3, poor 4. There's certainly nothing wrong with that, but at the same time, it might create some issues when we get to the interpretation, because presumably excellent is more favorable than poor. And when we talk about more of something, whether it's favoritism or quantity, we generally associate more with being higher values. And so even though it might seem out of order in our particular presentation, for actually assigning values, we might decide, well, let's let excellent be 4, good 3, fair 2, poor 1, and then not offered, we could let it be 0 if we wanted to, or again, we can treat it along the same lines of the don't know, whereas the don't know, previously we did 99, the not offered, we might come up with another unique option. We might make it 88 or something along those lines. And then as we continue on down, again, we have a yes, no, don't know. So again, we've already encountered that type of response. So common sense logic would suggest that we would keep the same type of coding. So we could say yes is 1, no is 0, and then don't know is going to be 99. Again, maybe we keep them as part of our analysis, maybe we delete it out. But because we're using that same number always for don't know, if we want to delete them all out at once, again, because they're the same values, it makes it a lot easier. And again, yes, no, don't know. So we'll have the 1, 0, 99. And then in our demographics, the how old are you, they're going to provide us the number. We don't need to fool with that. Female, male, again, we'll just make a decision in terms of female being 1, male being 2. Hispanic, again, we got to have the yes, no, don't know, so 1, 0, and 99. Races, 1, 2, 3, 4, 5, and then we can let 6 be other. And then finally, our last question was income. Again, because this isn't ordering, we do want to pay attention to how we order this. Again, just for simplicity, the easiest thing is to let the first category be 1 and then just increase from there. So we would actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then don't know, again, we could turn into 99. So that's the basic idea behind the code book. And whenever you create a code book, always make sure that while you may have this in your head that this is what we want, and we haven't made any markings or notations on this, certainly if we were doing this for real, we would actually want to have a printed copy of this, where on the printed copy we write out beside each of the responses what the corresponding numerical entry is going to be, and then we keep that in a safe place. It's no different than having a key for a test or an assignment. This is the same thing. It's a key that will allow us to explain and interpret what these different numbers represent. So now that we've created our code book, we can return to Excel and begin the process of converting all of these numerical things into all of these verbal things into our numerical values. Now, one advantage to the process that we're going to use is that we can select multiple columns as long as those columns are going to be recoded the same way. So, for example, if we know these first columns A through G were all part of that first recruitment rating scale that had the yes, no, and do not know, then what we can do is actually go through, select the entire set, and do a find and replace all at one time. Now, as straightforward as this process might seem, there are instances where we have to think a little bit. This is particularly relevant when we have strongly agree to strongly disagree type responses. We have a similar situation in this case. For example, we might just jump in head first and come up to our edit menu. We want to choose the replace option, and we say, well, we're going to replace yes with a 1. We want to replace all of them in our selected area. You can see from what has happened, all of the yeses have now been replaced with 1s. We still have the no's, and we still have the do not know. Now, if we just continued, what we might do is say, well, the next item on the list was no. Let's change no to be a 2. Well, if we say no and we want that to be a 2, then we replace all of them. Then we actually have created a problem, because this particular cell, close this particular cell was actually do not know. Well, it looked for the string of characters NO, and we said replace it with a 2. And so what happened was it saw NO in that cell and replaced it with a 2. And so now this cell no longer says do not know. So in our sequencing, we would actually need to replace the do not know cells before we replace the simple no cells. This is similar in nature if we had the strongly agree to strongly disagree. If we said, well, let's replace the strongly agrees and let's replace the agrees. Well, if we replace the agrees, it's going to replace all of the cells that only had agree in it, but all of the cells that had strongly disagree might end up being strongly dis 2 or strongly dis 3, whatever your value happens to be. The disagree is going to be dis 2 or dis 3. And so we actually want to step back and say, okay, well, strongly disagree, if we do that one, then it won't affect any of the others. Then we can do disagree. Then we want to do strongly agree, and then finally agree, and so that we don't end up with cells that look like this. So if we simply run into a situation where that happened, and it's no problem. Nice thing with modern software, you just go up, you click undo. Notice it also undid our yeses. Again, not a problem. We can simply go up, do our replace. We want to replace yes with 1. We'll replace all of them. We want to replace do not know, and those were 99s. And then finally, we can replace our no's with a 0 and replace all of them. And now you can see that we have our 0s and 1s that are representing our yes no's, and we have our 99s down here to represent our do not knows. Now again, as we scroll across and we have the second rating scale, in between we also had the type of facility. And again, it is important, and this is where you may want to expand your cell a little bit so that you can see exactly what the responses are, because when we do our find and replace, in most cases the wording will be an exact match to the actual response item from the survey, but we need to make certain of that. And so we can look at this and we can see, okay, for instance, if we were to jump back to our survey and we looked at the training location, the initial response was at a community college. But when the data was actually recorded and brought over, the at a did not come with it. So it was just community college. So when we do our find and replace, all we need to do is search for community college, replace that with a 2, and then the same with the other responses. So again, just to kind of go through one more example, if we have our second rating scale, we had the poor, fair, excellent, and then good in between. Now the one advantage to these is that there's no overlap here. So in this one we can actually work in virtually any order that we want. And so we can simply come up and do a replace. Let's start with excellent, and we want excellent to be represented by a 4. And then we will do good, that is represented with a 3. And you can see in the background the various words being replaced with the numbers. We want fair to be a 2. And then finally we want poor to be a 1. Now at this point we would have to look and see, we do have a not offered, so we can do not offered, and we mentioned that one we will do an 88 just so that it's separate and distinct enough from the 1 through 4s that really are the ones that we're probably the most interested in. We'll replace all, and then at this point we would need to decide, do we have any don't knows? And of course, if so, we would need to know actually what the wording is. And at this point, it doesn't look like we have any, and so we could simply close our find and replace, and we have finished out that second actual rating scale. And this process would simply continue through the last rating scale, through the demographics, until everything has been converted out of the word format into the numerical format. And that finishes our overview of the recoding of the original wording response into the numerical responses that will allow us to conduct our needed analyses.